Now let me show you the details of each step. Step 1. We want to convert the volume and density into the mass of methanol. The mass equal to density multiply the volume. Milliliter, they will cancel. After we punch all numbers into a calculator, we get 21.3 gram. Step 2. We will convert the mass of methanol into the moles of methanol. We need to calculate the molar mass first. Each methanol molecule contains 1 carbon. If you look up a periodic table, you will find that atomic mass of carbon is 12.01. We only have 1 carbon atom in the molecule. The atomic mass of hydrogen is 1.008. We have 8 hydrogen atoms in the molecule. The atomic mass of oxygen is 16.00. We only have 1 oxygen atom in the molecule. After we punch all the numbers into a calculator, we get 32.042. The unit is gram per mole. After we punch the numbers into a calculator, we get 0.665 mole. Because we have many chemicals, so it's better to write down the chemical formula behind the number and the unit. Step 3. We need to convert the volume, pressure, and temperature into moles of oxygen gas. We need to use the ideal gas law. The pressure of oxygen gas is 1 atmospheric pressure. And the volume of oxygen gas is 12.5 liters. R is a constant. The temperature is 273 Kelvin. Atmospheric pressure will cancel. Liter and liter will cancel. Kelvin and Kelvin will cancel. The unit we get will be moles. After we punch all numbers into a calculator, we get 0.558 moles. Since we have many chemicals in this problem, so we'd better put down the formula behind the number and the unit. Step 4. We need to decide which one is the limiting reactant. Since we are looking for the moles of water for the next step, so we can combine this calculation into one step. We assume methanol is a limiting reactant and calculate how many moles of water we can produce. Then we assume oxygen is a limiting reactant and we can calculate how many moles of water we can produce. Whichever give a smaller number of moles of water will be the limiting reactant, and the smaller number of water will be the moles of water we can produce. We have 0.665 moles of methanol. We need the conversion factor from the balanced chemical equation. For every 2 moles of methanol, we will produce 4 moles of water. After we punch all the numbers into a calculator, we get 1.33 moles of water. Then we need to assume oxygen is the limiting reactant. We have 0.558 moles of oxygen. And the balanced chemical equation tells us every 3 moles of oxygen gas, we will produce 4 moles of water. we will produce 0.744 moles of water if oxygen is the limiting reactant. This number is smaller than this number, so oxygen is the limiting reactant. The amount of water we will produce is 0.744 moles of water. Then we will proceed to step 5. We need to convert the moles of water into gram of water. We need to calculate the molar mass of water. For 1 mole of water, it contains 2 moles of hydrogen. And each mole of hydrogen is 1.008 gram. And we have 1 mole of oxygen, which is 16.00 gram. We only have 1 mole. We get 18.016 gram per mole. This is the molar mass for water. We can produce 0.744 moles of water, and for every 1 mole of water, it will be 18.016 gram. And we get 13.4 gram of water. Let's do the last step, step 6. We need to convert the mass and density into the volume. Volume equal to mass over density. 13.4 gram and the density is 1.00 gram per milliliter. What we get is 13.4 milliliter of water. And this will be our final answer. At the end, I want to emphasize, in an exam or a quiz, you only need to turn in what is on the right side of this paper. And this part should be on your scratch paper. But if you put them into an exam paper, I will not deduct any point.